Hello, Physics Nation. My name is Nate Lerman. I'd like to do a Khan Academy problem from calculating average acceleration from graphs. So we have a cat chasing a mouse until the cat gets tired. A graph of the cat's velocity over time is shown below. Okay, so we start at 0 meters per second, accelerate for 12 seconds up to 8 meters per second. That's super fast. And then gently decelerate from 8 meters per second down to 0. Notice Khan likes to chop it up into different time intervals, so we're actually only interested in the second half of this graph. We start at 8 meters per second right here, and we end at 0 meters per second. So the change is -8. Pardon my sloppiness, and it takes 12 seconds. And we can get our happy confetti now, but I'd like to do, where is it? Sorry, I'd like to do a traditional hand-drawn solution. Oh, shoot, I drew a squirrel. Well, whatever. Our squirrel is moving to the right, and we're getting faster, faster, faster. So there are lots of different ways to represent motion. You could do velocity vectors. These are stroboscopic representations. That is, just imagine a strobe light. There's the cat. There's the cat. There's the cat. So if the spacing increases, we're getting faster, faster, faster until 12 seconds arrives, and we stop getting faster. So now the spacing, that is the displacement, shrinks. In between each time interval, how far the cat or the squirrel goes is its velocity, its rate of change of position. So we've looked at a lot of position versus time graphs. Now we're looking at velocity versus time graphs. And mathematically, it's just a slope calculation, but now the slope means something different. This slope is the rate of change of velocity, in other words, acceleration. So this is how we find acceleration. Here's the change in velocity. Here's the elapsed time to make the change. The math teachers just say X and Y, so you've done a million slope calculations. At 12 seconds, we're moving 8 meters per second, and then x2, y2. At 24 seconds, you're moving 0 meters per second. So the game we play in physics class over and over again is replace the math teacher's x, or independent variable, with our, physical thing, in this case, time and velocity. So the initial time is 12 seconds, the initial velocity is 8 meters per second. The final time is 24 seconds, and the final velocity is 0 meters per second. I messed up my ordered pairs. Final minus initial is 0 minus 8 meters per second, so we drop 8 meters per second. Let's see, our cat is, hang on. Our cat is going faster, 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 and then slower, slower, slower. So halfway through the motion in time, we start to decelerate. We're moving 8 meters per second, and then we slow down. It takes 12 seconds to drop those 8 meters per second, so that's -2/3 of a meter per second every second. So, after going 8 meters per second, if you drop 2/3 of a meter per second, 1 second later, you're moving 7 1/3 meters per second. 2 seconds later, you're moving 6 2/3 meters per second. So every second, we are changing by 0.67, or 2/3 of a meter per second. And let's see if we can get the happy confetti here. -0.67 meters per second per second. Hey, and there's the happy confetti. Thanks for watching. See you in the next video.